Hello everyone. Now we are going to discuss about the chiral and achiral molecules. What is this chiral molecule? Normally, carbon atoms that contain four different groups or atoms are known as asymmetric carbon atom. So, to the carbon is having the four valency. To that valency, four different groups or atoms are attached to the same carbon atom. They are known as asymmetric carbon atom. And its mirror images are not superimposable on each other, and they rotate the plane polarized light into the opposite direction. They are known as chiral molecules. Here we have taken the example. Here this is the D lactic acid and L lactic acid. These two mirror images, they are not superimposable. That D lactic acid rotate the plane polarized light into the clockwise direction, whereas L lactic acid rotate the plane polarized light into the anti-clockwise direction. Hence it is chiral molecule. So four different groups or atoms are attached and they are not mirror images. They rotate the plane polarized light into the opposite direction. They are called as chiral molecules. So what is this achiral molecules? A molecule whose mirror images are superimposable and they contain at least one element of the symmetry, that is plane of symmetry, center of symmetry and alternating axis of symmetry. If it is having any one of the symmetry, such a molecule is known as achiral molecule. Even though they contain four different groups or atoms are attached to that one, they are called as achiral molecule. Let us see the example for the achiral molecule. So this is the example, that is meso 2,3-dichloro butane and meso tartaric acid. These two are example for that achiral molecule. Here you will find that compound. It contains two asymmetric carbon atom. Even though they contain two asymmetric carbon atom, if you divide the molecule into two equal halves, the same environment is present in the opposite direction. Hence, it is not optically active and it is known as achiral molecule. So, let us see what is the three elements of symmetry. There are three elements of symmetry. One is plane of symmetry, second one is center of symmetry, and third one is alternating axis of symmetry. So, what is this plane of symmetry? So, plane of symmetry, it is an imaginary line which divides or bisects the molecule into two equal halves. You will find the structure here, that is meso tartaric acid. So, this line, you will find the line. So, it divides the molecule into two equal halves. If you find that one, the same environment is present in the opposite direction. Similarly, 2,3-dichloro-butane. It is here also it is an imaginary line that bisects the molecule into two equal halves. So here also same environment is present in the opposite direction. Hence it is optically inactive. The second one is center of symmetry. It is the point in the center from which a line is drawn through the molecule, which presents the same environment in the opposite direction. Here you will find that one. This is the point in the center. So it divides the molecule into two equal halves. That is oppositely same environment is present. Hence that it is not optically active. This is called as center of symmetry. Here one point will be the same environment. You will identify that one. The hydrogen is present, hydrogen is present. Similarly, methyl and methyl group is present. So the same environment is present. It is known as center of symmetry. The third one is alternating axis of symmetry. So what is this alternating axis of symmetry? It is the line passes through the molecule so that it causes the rotation of 360 degree divided by n. So what is this? So if you are rotate the molecule for one time, then n will be 1. If it is 2 times, means n will be 2. So n is called number of rotations. So the rotation of 360 degree divided by n results in the stereoisomer which is identical to the previous one. So it is a line that passes through the molecule so that it causes the rotation of 360 degree divided by n, so which will result the stereoisomer which is identical to the previous one. You will find here, this is the example for alternating axis of symmetry, which is otherwise known as rotation reflex symmetry. Here this is the example, that is 1, 2, 3, 4 tetramethyl cyclobutane. If you are rotating the molecule for one time, it will also cause the same environment. So that one is known as alternating axis of symmetry. So achiral molecules, normally they are having the these elements of symmetry, that is plane of symmetry, center of symmetry, or alternating axis of symmetry. If any one of the symmetry is present, even though that chiral, even though they are called as asymmetric carbon atom, but they are not optically active. They are achiral molecules. So this is about the chiral and achiral molecules. I hope you could understand the chiral and achiral molecules and the various symmetry, that is such as plane of symmetry, center of symmetry, and axis of symmetry. I hope you could understand. Thank you all.